Alright, this is video 1.4 from geometry. Today we're going to be talking about the different kinds of pairs of angles you can have. So adjacent angles are going to be two angles that have a common vertex and a common side, but they don't share common interior points. So if we had this angle here and we said this was angle 1 and this was angle 2, they have a common vertex, they have a common side, but we're talking about two separate angles. We're talking about this angle and this angle, not angle 1 and angle 3. All right, so angle 1 and angle 2 would be adjacent angles. If you have two adjacent angles whose non-common sides are opposite rays, so opposite rays means they form a line, right? And so let's say here's our vertex and there's our other one. Let's say that this is angle 1 and this is angle 2. If angle 1 and angle 2 are adjacent because they share a common side, but their opposite sides, their non-common sides, form a line, then we would call them a linear pair. So you can be an adjacent angle and not be a linear pair, but you can't be a linear pair without being an adjacent angle. So let's do some identifying of angle pairs. What we're looking to say is whether they are adjacent angles, if they're adjacent and linear, or if they are non-adjacent angles. So let's look at angle 1 and angle 2. Angle 1 is here, angle 2 is here. So do they have a common vertex and a common side? They do, so they are definitely adjacent. The next question is, do their non-common sides form a straight line? These do not, so they are not linear. Let's look at 2 and 4. Here's angle 2 and here's angle 4. Do they have a common endpoint, common vertex, and a common side? They do not. They are not adjacent. So we would say these are non-adjacent. And if they can't be adjacent, then they can't be linear. So we can be done with those angles. Angle 1 and angle 3. Angle 1 is here. Angle 3 is there. Do they have a common vertex? Yes, right here. Do they have a common side? Yes, right here. So these are, whoops, wrong side, adjacent. And do their non-adjacent sides form a straight line? They appear to, so we would say that these are also linear. Complementary and supplementary angles are something that's super important that you remember which one is which. So go ahead and get it memorized. Complementary angles are going to be a 90-degree angle. Supplementary are going to be a 180-degree angle. Go ahead and get those memorized because you're going to need to be able to pull that information very quickly from your mind. So if you have two angles that are complementary, it means that when you add up the sum of their angles, they add up to 90 degrees, while supplementary angles are going to measure up to 180. So we can use these to solve just using some basic algebra, knowing that the sum of the angles have to equal 90. So let's find the measure of some complements and supplementary angles. Let's say we want the complement of angle M. Well, here in our figure, we see that M's angle is 26.8. So its complement means that the number that we could add to 26.8, complement means it needs to add up to 90. So the way we can solve this is we can say a 90 degrees minus 26.8 is going to give us what's left over, which would be the complement. So 90 minus 26.8 is 63.2 degrees. So the complement of angle M would be 63.2 degrees. So let's find the supplement of angle N. Here, angle N, we haven't been given an exact number. We've been given an equation here, an expression. And so our answer isn't going to have an exact number either. So supplement, that means that it's a 180, so 180 degrees minus the one we have, which would be a 2y plus 20. Now, here's where you got to be careful if you recall from algebra. If you have a negative sign out in front, that negative sign is going to go in and change all of your signs. So that would be 180 minus 2y minus 20. Go ahead and combine like terms. We have our 180 minus our 20 is 160. So we would say the closest that we can get to having an actual degree would be 160 minus 2y. I'm going to go ahead and put that in parentheses so we know that they all stay together with our degree sign on the outside. So the supplement of angle N is going to be 160 minus 2y. So once you find out what y is, then you would be able to solve for what the actual angles are. So the first thing I'm going to do is I'm going to name the angles that we're talking about here. Let's say the angle that we're looking at is angle A. We're just going to call that x. And we need to have the complement of A. We'll call that B. All right. So B, because they're complements, we could say is 90 minus x. The other thing that we know about A is that it is twice the complement. So that would be 2 times the measure of angle B, right? And then 3 degrees less than that, so minus 3. That's what A is also equal to. So we could say that angle A, we're going to call it x, and we know that angle x, or angle A, is twice the measure of the complement, which that's twice the measure of angle B, minus 3 degrees. Now I'm going to take these two and I'm going to put them together. So if I know that angle A is equal to x and angle A is equal to this, then I can put them together. So I'm going to say that angle A is equal to angle A. And angle A over here is 2 times the measure of angle B minus 3. Now I'm just going to solve for x. So I'm going to distribute my 2 to my 90 and distribute my 2 to my x. So I'll have x is equal to 180 minus 2x minus 3. I'm going to gather my x's. So I'm going to add 2x to both sides, giving me 3x is equal to, I'm going to do my 180 minus my 3, which would be a 177. Now I'm going to divide by 3, giving me x is equal to 59. Now that does not tell me what the complement measures. That just tells me what x is. The complement is going to be 90 minus x. So the measure of angle B is going to be 90 minus x. So that would be 90 minus 59, giving me that angle B is equal to 31 degrees. So let me go back over those steps really quickly. So the first thing I did is I named my two angles, angle A and angle B. We know that they add up to 90. So I'm saying angle A is x. Angle B has to be 90 minus x because the two have to add up together to make 90. From the information given, I know that angle A is 2 times the measure of angle B and then 3 degrees less than that. So I have 2 times the measure of angle B minus 3. Now, angle A is equal to angle A, so I can take this one and put them together right here. So I have x, which is the measure of angle A, and I have 2 times 90 minus x minus 3, because that is also the measure of angle A. I gathered my x's together to solve for x, substitute my x in to find my complementary angle right here. Vertical angles is another type of angle that you can have. So if you have two non-adjacent angles, that means they do not share a side. They may share a common endpoint, but they do not have a common side. We always say that vertical angles are the same size. Here's what I'm talking about. If you have two intersecting lines, you make 4 angles out of it. You make the angle on top, number 2, number 3, and number 4. The non-adjacent angles, so 1 and 4 are adjacent, 2 and 3 are adjacent, 1 and 2 are adjacent, and 3 and 4 are adjacent. So we're looking for the two non-adjacent angles that are formed. Those are going to be congruent. So they're always going to be a little opposite of each other. So if one is adjacent to 2 and to 4, the one it's not adjacent to is going to be 3. So angles 1 and angle 3 are vertical angles. Likewise, angle 2 and angle 4 are vertical angles. So what we can say from that is that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. When you come to class tomorrow, be sure that you're able to look at a picture and decide whether angles are adjacent, linear pairs, or not adjacent, just like we did in the first example. Be able to find the measure of a complement, to be able to find the measure of a supplement, and then be able to find vertical angles from looking at a figure. Have a great afternoon.